we're looking at some problems in Cal 1 under integration, and we're going to be looking at the technique of U-Substitution. And we're going to start off with doing some indefinite integration. So know the difference between indefinite integration and definite integration. Definite integration, like in the previous videos where we have bounds, you'll see I don't think it was in the previous one, but back when we was doing some definite integration, you'll see a number here and then possibly a number up here, and that's definite. This is indefinite. I think we worked some of these earlier in the story. But let's say that we had x plus 1 raised to the 4th power dx. Now you could, I just don't suggest this, multiply x plus 1 times x plus 1 and get out some polynomial, and then from the previous techniques of integration we could do this, but man, what happens if there was 100 up here? Alright, we couldn't do that. So what we're going to do here is we're going to use what's called U-substitution, and we're going to let u equal x plus 1. Now we're going to have to take the derivative of this, and du over dx is equal to, so the derivative of x plus 1 is just 1. Now what we're going to do is actually the substitution. So the x plus 1 is going to get substituted, right, with the u, because u is equal to x plus 1, but remember it's raised to the 4th power, times in the dx, and what we're going to do here is we're going to solve for du. Just bringing this dx diagonally up, and so we have du is equal to 1 dx. Well, there it is, and so this becomes du. Now it's in a form that we know how to do the indefinite integral. So we add 1 to the exponent, putting the exponent down below, and then remember we have to say plus c here on the end. But we're not finished. What we got to do now is go back and substitute back in. So we have the x plus 1 raised to the 5th power, and it's all over 5 plus c. So that's what this guy would be equal to without just rewriting it up here. Now you can always check your work by taking the derivative of this, and let's just do that. So let's take the derivative of this, and so we end up with 5 x plus 1, right? Ooh, that's a 1 there. Take the 5, bring it out front, subtract 1. Of course, remember we still got this 5 down here in the denominator, and then we take the derivative of x plus 1, which is just 1, and the derivative of c, of course, is 0. But when we simplify all this down, we get x plus 1 raised to the 4th power, and that's what we started with, x plus 1 raised to the 4th power. So you can always check your work. You can always check your work. So let's look at another one here. This would be slightly different. So we're going to have the integral of 1 minus 4x raised to the 7th power. We're going to throw in a negative 4 here. I know normally you wouldn't write it like this, but there's a reason why we're doing this. So we let u equal 1 minus 4x. Usually whatever's in parentheses is what we're going to let be our u. And we have du over dx is equal to, so we take the derivative of this guy and we get negative 4. But we want to solve for the du. And there you go. So as you can see, we can do the substitution. That's going to get replaced, and this piece here is going to get replaced. And so we end up with the integral of u to the 7th times du. And then we can easily do this, and then plus c, and then go back and substitute back in. raised to the 8th power, and of course it's over 8, and then we have plus c. So we have found the indefinite integral of, I think I passed it up, of this right here. That was the previous problem. I think I'm going to clear out the screen here, and we can start over. Alright, so the problems are going to get a little bit more difficult. We have the integral, and we never did check that by differentiation, but I'll let you do that. We've got the integral of the square root erase that. I was getting kind of sloppy. We have the integral of t times the square root. I'm not sure that's any better. Of t squared plus 2, then dt. So what we're going to do now is we're going to let, what are we going to let? We're going to let this stuff under here be our u. So u, we'll write it out here to the side, is equal to t squared plus 2, and then let's take the derivative of that. Du is equal to 2t dt. We have a dt and a t, but we don't have a 2 in here. I'm going to write that. I'm going to put that as a different color. So what we're going to do is we're going to force it in here. We're going to put a 2 here, but we must put a half outside. You see, because a half times 2 is just 1. So we really hadn't done anything. Now we're going to go through and do the substitution. We got the integral. So the 2t and the dt is going to get replaced with a du. But first let's write our u. And instead of writing the radical here, I'm going to go ahead and just raise it to the half power. Don't forget this half out front. Now we can go ahead and take the integral. So we have a half, and this becomes u, adding 1 to the exponent. So that becomes a 3/2, putting the 3/2 down below, and then plus c. But what we want to do now is, I noticed something here. Yeah, somehow that got zoomed in. I knew that didn't look right. Alright, where are we at? Slowing me down. So we have, let's actually go ahead and try to simplify this down here a little more. We have a half times, flipping that, that's going to be 2/3. Yeah, I think that looks a little better. 3/2 plus c. Okay, substituting back the u here, so we're going to have t squared plus 2, and it's going to all be raised to the 3/2. And of course it's over, so half times 2/3 is 1/3. We'll just put the 3 out here. Now of course you can take the derivative of this, and we should get back what our original integrand was. Let's see, bring the 3/2 out front, subtract, you have a half, 3/2, yeah, okay, 2, and then, yeah, 2t, 2's cancel out, yep, that's it. So there you go. So these problems are getting a little bit longer here in calculus. Time to look at another one. I had to clear the board. Okay. What do I have going on next? Ooh, look at that one. That looks like a good one there. Well, I guess maybe we ought to write it down. We have the integral of x over 1 minus x squared raised to the third power dx. Usually what's in parentheses or under a radical is what we're going to let be our u. So let's go ahead and try that out. U is equal to 1 minus x squared. Our du, go ahead and take the derivative of that. We have negative 2x dx. We have an x and a dx, but what we don't have is a negative 2. So we're going to write a negative 2 in there. And I'll do that in a different color. How's that? Negative 2, but if I put a negative 2 in here, we got to put a negative half outside. Now we can do our substitution, rewriting the negative a half. So the negative 2x dx gets replaced, and du is going to replace it. But I'm going to go ahead and write that du out here to the side. And then this is 1 minus x squared. Of course, that is our u. And it's raised to the third power. We want to go ahead and rewrite this one more time before we actually take the integral of it. So we're going to write that, raise it up there. Of course, we've got to change the exponent, so we take it up into the numerator, and then we do the du. Now we can finally do the calculus. Adding 1 to the exponent, that gives us a negative 2. Putting the negative 2 down here in the denominator, and then of course plus c. Now we want to go back and do our, well actually, let's do this first. I'm going to take this negative and bring it out front. 2 times 2 is 4. And let's take that u down into the denominator. There we go. And now we can go back and do our back substitution, I guess you want to call it. And remember, our u is equal to 1 minus x squared. So we have 1 minus x squared, and the whole thing is squared. I know this is not very neat, but hang in there. Now we can always check our work by taking the derivative of our answer, and of course we should get back the integrand here. And if we don't, we either took the derivative wrong or we took the integral wrong. Something's wrong. What do I want to do? Nah, I guess nothing. We'll get started. You take the derivative and check, see if that's right or not. Alright, let's get started on another problem. This one here will be a slight twist on U-substitution. We've got the integral of x times the square root of x plus 2 dx. Now we're going to let what's under the radical be, we'll let that be the u, where the u is equal to. And now we're going to have to do something a little bit different. Because when I take the derivative of this, du is equal to 1 dx, as you can see here we have a dx, but we also have an x here. So what are we going to substitute for this x? That's the question. We're going to have to go back into here, and what we can do is a trick. And what we're going to do is we're going to solve for x in this problem here. So we're going to have u minus 2 is equal to x. So now we can substitute this x right here for u minus 2. We're going to go ahead and do all of that right now. And of course we have the square root, but you know what? I'm going to go ahead and skip that step and just write u to the half power so we don't have to do that again. And then dx, remember, gets replaced with the du. There you go. So this was a little bit of a trick to get there. Now what I'm going to do is I'm going to go ahead and distribute this u across inside the parentheses. So we have u times u to the half minus 2 times u to the half. Let's put parentheses around all this, and then times du. But we still want to clean it up a little bit before we actually do any calculus. I should be writing equal signs here. We have 1 plus a half, so this becomes u to the 3 halves minus 2u to the half, and then du. Now we can actually do some calculus. We'll just scroll on down the screen. We got plenty of board. So we add 1 to the exponent. We end up with u to the 5 halves over 5 halves minus 2 times u adding, so we have 3 halves, and that's over 3 halves. And don't forget the c, or you're going to be in trouble. Take this, we're going to flip that around, so we have 2/5 u to the 5 halves, and then we flip that, so we end up with, what do we end up with? I think 4/3, right? Yeah. So 4/3 u to the 3 halves plus c. Now we go back and do the back substitution, substitute it back. Right, so we want to take that x plus 2 and plug it in wherever there's a u. So scrolling equals 2/5 times, and this is going to be x plus 2 raised to the 5 halves minus 4/3 x plus 2 raised to the 3 halves, and then plus c. Now you can do some factoring if you want. You can factor out an x plus 2 raised to the 3 halves. You can actually pull that out of there. I'm just going to leave it alone. Let you work on that. Alright. We better get started on this problem, because this is not going to be an easy one here. We've got the integral of x times the square root. I mean, it's similar to what we just got through doing actually. Maybe it's a little longer. 2x plus 3 dx. So once again, what's in parentheses under the radical most of the time is what we're going to let be our u. Now let's go ahead and take the derivatives. We have du is equal to 2 dx. Now I'm going to do something here. See, there we have a 2 dx. We don't have a 2 in here. We've got a dx. We're going to end up writing a 2 in here, but we have to remember put a half outside. But what about this x here? We got to do something with that, and like we did in the previous problem, I'm going to take this equation up here and solve for x. So we have u minus 3 over 2 will be our x. So we just solved for x in this equation. If I got that right, solving for x, solve for x, yeah. Okay, and now we can go ahead and substitute that x now. So we have a half the integral. So we have the 2x and the dx. Of course, you know, they're going to all be replaced. The 2 and the dx is here, and that's going to get replaced with the du. And I'll write that here in just a minute. This x is going to get replaced with the u minus 3 over 2. And then, of course, I'm going to go ahead and get this out of radical form and into exponential form. This becomes u raised to the half. I guess I didn't have to put that in parentheses, but I did it anyway. And then that dx gets replaced with the du. actually the 2 and the dx gets replaced with the du. Now what I'm going to do is go ahead and take this half and bring it out front. Just get that out of the way. So we're going to have a fourth, the integral of u minus 3. I think I need to step up my time here. U to the half du. Now I'm going to go ahead and distribute this u across inside here. We have a fourth times u, and this is going to end up being 3 halves, minus 3 times u to the half. Right, we just distributed the u to the half across each one of those terms there. Now we can finally take the integral. And so we end up, and I should be writing equal signs out here. These are all equal. And I'm going to write 1/4. I'm going to start a bracket here. So this becomes u to the 5 halves over 5 halves minus 3 times u to the 3 halves, right? Adding 1 to the exponent and putting 3 halves down below. And trying to clean this up a little bit, we're going to end up having, go ahead, rewrite that 1/4 out here. So this is 2/5 u to the 5 halves. So once I get done writing this, let's see, this is going to be 2 over 3, but the 3's will cancel out, so we'll just be left with a 2. Alright, a 2 u to the 3 halves. I'm going to go ahead and distribute that 1/4 across. So this is going to end up being 1 over 10. And I'm going to go ahead and fill that u back in again. So this was 2x plus 3 raised to the 5 halves minus 1/4 times 2 is a half. And so we have 2x plus 3 raised to the 3 halves. And you can factor some stuff out in here if you like. Yeah, okay, looks good. Just checking to make sure everything is kosher, and it is.